Good afternoon, students, or I should say student. Can you just give me an indication that you can hear me, Miss Izona? Thank you very much. Okay, can you see what I'm sharing at the moment? Thank you. Thank you. Okay. Now feel free to ask me or stop me at any point if you would like to me to explain something again, or if you have any questions at all. If you do have questions, just ask me, please. Otherwise, I'm just going to be doing some practice problems. Is that okay? Okay, let's go over to some practice problems. This is problem number 6. The number of the problem is not important. Okay, it's the actual problem. Okay, so the question asks, okay, a 1.5 kilogram object. Okay, so a 1.5 kilogram object has a velocity of 5 meters per second at time 0. It is accelerated at a constant rate for 5 seconds, after which it has a velocity of 6I plus 12J. Okay, in there it should actually be 6I plus 12J, not 6 plus 12 meters per second. This is what it should be. Okay, so if you are writing this down or looking at it somewhere in the future, please note that. Now they ask us, what is the magnitude of the resultant force acting on the object during this time interval? Okay, now they want the resultant force. Okay, now in order to get force, we know that force is equal to mass times acceleration. We have the mass. Okay, we have the mass. We've been given the mass as 1.5 kilograms. We need the acceleration. Can we get the acceleration? Can we get the acceleration? Okay, they tell us that it has a velocity of 5 meters per second at the beginning, and then after 5 seconds it has a velocity of 6I plus 12J meters per second, and then in that time interval of 5 seconds. So let me write all of it down. Our initial velocity is equal to 5I hat meters per second. Right? And then our final velocity is equal to 6I hat plus 12J hat, and that is of course in meters per second. Let me just include that as well. That's in meters per second, and we have a time of 5 seconds. So that's the time, 5 seconds. Now how do we calculate acceleration? We know that acceleration is nothing but the change in velocity over time. Okay? That is acceleration. Okay? So you can actually plug in what you've been given. Okay? You can plug in what you've been given. Let me just check. If you have any questions at any point, just stop me and then ask. Okay. So we have that the acceleration is equal to the velocity at the end minus the velocity initial over the time it took to get to that final velocity. Now we know that the initial velocity is equal to or let's rather start with the final velocity. So we'll write the final velocity is equal to 6I hat plus 12 j hat minus, this is minus now the initial velocity, which is 5I hat. And I know that the problem itself does not specific or is written down wrong. It does not have the I hat after 5 meters per second, and it doesn't have the I hat and j hat after 6I hat plus 12 meters per second. So my apologies for that. We need to fix that. But that's not a problem. I did write down the initial velocity and the final velocity and the time it took to get to the final velocity. Remember, we are still interested in the force. So what is the time it took to get to that? It's 5 seconds. Okay? And I know my 5 looks like an S as well. Let me try and see if I can draw it better. 5 seconds. This gives us 6I hat minus 5I hat. It's just I hat. Oh, sorry, this is supposed to be 5J hat. This is not 5I hat, it's supposed to be 5J hat. 5J hat, so this would then be, we just fix that. So this would be 0I hat plus 5J hat. It's supposed to be 0I hat 5J hat. Okay. Same problem, still the same problem. It's just that it wasn't, I assumed it was I hat, it's just J hat. So we have that 6I hat minus 0I hat is just 6I hat plus 12J hat minus 5J hat is just, that is 7J hat. Okay, over 5 seconds. That's over 5 seconds. Now if you were to divide that, let's do the, this is your velocity, your acceleration, excuse me, and it is 6I hat minus 7J hat, and I'm not going to include the hat. You should of course include the hats all the time, divided by 5. If you divide each one individually by 5, you get 1.2 I hat minus, now remember this is a speed. Originally we had speed which was in meters per second, and then the denominator in this case was in seconds, so it's meters per second squared, which is the units of acceleration. At this point it is then 1.4, 7 divided by 5 is 1.4 j hat. Okay, so this is the acceleration. Okay, this is the acceleration in vector form, but we don't want it in vector form. We want the value of the acceleration, in other words the magnitude of the acceleration. Can I just ask then, can any one of you tell me how would I get the magnitude of the acceleration from this format? How would I get the magnitude of the acceleration? Any one of you? Can any one of you tell me
can
how?
get
Yes, go ahead.
you can get the magnitude of the acceleration by summing the two, like taking the square root of 1.2 plus negative 1.4.
Yes, I'm taking the square root, but you forgot something. You are correct, yes. But you forgot something. You did not include something. I would be taking the square root of 1.2. You'll see now what you forgot. There's something you forgot.
Oh, 1.2 squared.
Thank you. Thank you. You are correct. Yes. That's it. That's how you would get the magnitude of this acceleration. Remember, we want the force. So if you were to do this, and I'm not going to do all of that, you can just punch it in your calculator exactly as it is. You can punch it in your calculator, and you would get an acceleration of 1,84 meters per second squared. And that's your acceleration. Okay. But remember, they asked originally in the question, let me just go to it. They asked, what is the magnitude of the resultant force acting on the object during this time interval? Can I just ask, and this is an open question, how do we know that there is a resultant force? How do we know that there is a resultant force? How do we know that that force is not zero? Any one of you guys would hazard a guess, or not just a guess? How do we know that this force is not zero? Look at this law here. How do we know the force is not zero? Remember, the mass is constant. If the mass is constant, but there is an acceleration, it means that there must be a force. Okay. And Tibashe, your mic was on there for a second and I could hear myself, which is not a nice sound, hearing myself. Okay. So everyone get that. The reason why I can say that there is a resultant force, or we can conclude that there is a resultant force, is because there's an acceleration. Its speed changes. Whenever speed of something changes or its direction changes, there is a resultant force. You should know that. Okay. Now we have an acceleration, we have a mass. We can calculate what force caused that acceleration. So we know that F is equal to ma from Newton's second law. We've been given that the mass is 1.5 kilograms, and please always make sure that when you use Newton's third law or second law, F is equal to ma, that the masses are in kilograms, please. I have seen quite a few students make the mistake of using masses that are in grams. Now, if you were to multiply that out, you would get to an answer in newtons, which in this case is 2,8 newtons. Okay. Did everyone get that? This kind of stuff goes quickly, guys. It's just applying brute force calculations. You need to just understand what is happening and then applying your formulas. In our case, there was an object, let's say a block, that started when at zero, which at zero time or at the start had an acceleration of 0j plus 0 I hat plus 5j hat, and then all of a sudden at the end it had a 6 I hat plus 12j hat velocity. Okay, which means its velocity changed, so some force was applied. Okay, so just always keep in mind, a trick I always used is to, or not a trick, something I always use to understand the question is to try and see if I can draw what is happening or picture what is happening. Okay, if you don't have time, picture what is happening. And if you can picture what is happening, you've already solved the question. You're halfway to solving the question. Then it's just plugging in the correct values and all of that. Okay, so question number 7. Don't worry about the numbers, just worry about the problems themselves. They tell us that a 2 kilogram block. So let me try and see if I can draw this. So we have a block, 2 kilograms. So a 2 kilogram block slides on a rough horizontal surface. Whenever you hear the word rough, you must immediately know friction. There will be friction. So that's a rough horizontal surface. And a force of magnitude 4 Newton is acting parallel to the surface. So parallel to the surface is a force of 4 newtons. P, it's been named P, and it is equal to 4 newtons. This is the force that is pushing this block. Now, the magnitude of the block's acceleration, so the block has an acceleration now because it's being pushed by a force. So the block has an acceleration. It's been pushed by, it has now has a net force. So the block's acceleration is 1.2 meters per second. So then they ask if the block's mass, if the force P is increased to 5 newtons, if this was to come 5 newtons, determine the magnitude of the block's new acceleration. Okay, so what would the acceleration now be if we increase the force? Let me just go check. I think there's someone inside the lobby. Okay. Isipo, welcome. Okay. So we have this force acting on this block, and we have this acceleration. Can someone ask me? Oh, well, can I just ask? Can someone tell me, rather, what is the first thing we need to work out? Can someone hazard a guess? What would be the first thing we need to work out? Right? Because it seems like a simple problem. Can someone please guide me in the correct direction? What would I first calculate? Okay, thank you, Sinesipo. Wonderful. Okay, I would first need to work out the friction, the force of friction. Avene, you too. I see you're typing. Thank you, guys. Yes, the forces. Okay, in this case, the force of friction. Okay, so in order to work out this problem, for the first one, we need to work out what is the friction. Okay, so Newton's law actually, in its correct form, says that the sum of all the forces is equal to the mass times the acceleration. Now, there are two forces currently working on this particular block. It is the force being applied, which we call P, and then we subtract the force of friction, which I'm going to write as F small subscript f, and that should be equal to MA. Now, we know what is M, the mass. We've been given what the mass is. It is, in this case, our mass is 2 kilograms. Okay, let me just fix this quickly. Our mass is 2 kilograms. Our mass is 2 kilograms. Our acceleration has been given as 1.2 meters per second squared. We were given that originally the force was 4 newtons. So we can now work out the force of friction. If we just make the force of friction the subject of the formula, we take it over to the right hand side, it becomes positive force of friction. And then of course this whole fraction goes over to the left hand side. This is in Newton, so it will be 4 newtons multiplied by 2 times 1 comma 2, which in this case is 2 comma 4 Newton, and that would be your force of friction. Okay, so the force of friction in this case is equal to, if I do my math correctly, 4 minus 2 minus 0.4, it is 1,6 newtons is the force of friction. Can someone just verify that that is correct? And yes, it is correct because I did check before I went here. I did work out all the problems myself. Does everyone understand by show of hands? You can understand what I did there or why I solved that first. Okay, thank you. So you guys all understand. Have some nice hands there. Hands up from Yanela and all of the guys. Okay, Sinosipa, you are out. You went out and now you're back. Welcome back, Sinosipa. Okay, so we've worked out the force of friction. That's why they gave us everything in the beginning, so we can work out one variable that was missing, the force of friction. Okay, now we have the force of friction. So they tell us, what did they tell us? They asked us if we were to increase the force to 5 newtons, what would be the block's new acceleration? So let's see. The sum of the forces is equal to mass times acceleration. We want the acceleration. So it would be equal to the sum of the forces divided by the mass. Now the sum of the forces would be P minus the force of friction and divided by the mass. In our case, P is now being increased to 5 newtons minus the original force of friction stays the same. The force of friction stays the same. And we calculated the force of friction to be 1,6 newtons. That would be your net force in the horizontal direction. And then we divide it by the mass, which in this case is 2 kilograms, which would give us the acceleration of the block if the force is increased to 5 newtons. Can I just ask, now, if we increase the force, the applied force P, if we increase it to 5 newtons, what is going to happen to the acceleration? The original acceleration was, let me just check, 1, no, where is it? 1.2. 1,2 meters per second was the original acceleration. Do you guys think it's going to be, the new acceleration, is it going to be higher or lower? And yes, I do realize that that is a stupid question to ask first year engineers and physicists, but I do ask it because sometimes in your multiple choice questions they ask you in forms of symbols what happens. Would the force increase? Would it decrease? Would it stay the same? Would the acceleration increase, decrease, or stay the same? And sometimes you guys just, not all of you, some of you guys just read it wrong. Can you guys tell me what's going to happen to the acceleration? What do you think is going to happen to the acceleration? Before you even calculate anything, what do you think would happen to the acceleration if I increase the applied force? Oh, yes. Isipo, yes. Thank you. And then, yes, Noneka. And then, Sinasipo. Thank you very much. Great explanation. Most of you, Yanela, I see you've already. Avene also typing. Yes, guys, most of you, well, everyone has it right. The force is, the acceleration is going to increase because of the applied force, like Sinasipo wrote there. It's going to be higher since the force applied is increased. The acceleration is directly proportional to the force applied. That is a textbook exam answer. That's how you would write it. Like Sinasipo wrote it there. Force is directly proportional to acceleration, which means if the force is increased, the acceleration would increase. Yes, thank you. I see Avena, you also wrote it perfectly. Exam type. I see you guys are ready for this part of the exam. Let me just okay, now let's work it out. 5 newtons minus 1,6. And guys, I sometimes skip this part of calculating the, well, not skip it. I have enough confidence in you to know, to ask, or to know that you can actually plug this into a calculator and work it out. Okay, the answer would be 1,7 newtons. Okay, that is the answer, 1,7 newtons. Okay, oh sorry, what did I do wrong? Can someone tell me quickly before I erase it? Someone tell
The
me wrong.
units.
Yes, thank you, thank you. I wrote the units wrong. I'm calculating here acceleration and I wrote down newtons. And whenever possible, try to use SI units. Okay? And if it's not specified, however, you can use. Sometimes students would ask, where do we stop rounding off and stuff like that. Work with the significant figures. Okay, in this case, it's 2 significant figures, so the least one has 1 significant figure. So, but in this case, we are not actually looking at significant figures. I just want to calculate that. Okay, if I was to look at significant figures, it's just a sidetrack now. It would be this one has 2 significant figures, this one has 2 significant figures, this one only has 1 significant figures because the trailing 0 is not significant. So the answer would then have to be 2 meters per second if we work with significant figures. Does everyone understand that? Okay, you must not forget those rules. Okay, let's go to question number 8. And guys, don't worry about where I got. Thanks there, Yanela. Don't worry about these problems that I'm doing here. As long as you understand what is happening, you can go back and check. I know if PHYV guys have access to these problems. Those other guys, no need to worry. You can just watch the videos and you'll see these problems. Okay. So question number 8. This is just for me. You need to just focus on the questions. A book is resting on a table. Okay, so we have a book resting on a table, and this one I'm going to let you guys do. It is resting on a table. How many forces would be in the free body diagram of the book? How many forces would be in the free diagram of the book? Can someone
I
tell me?
think that
Just write a number in the chat there. Would it be A, B, C, D, or E? Those are your options. Is there only going to be one force? Will there be two forces of the same type? Will there be two forces of different types? Will there be three or more forces of the same type? Will there be three or more of at least two different types? Now, this is only, I know some of you guys are extremely smart and you're going to start saying the strong nuclear force, the weak nuclear force between the atoms and stuff. That would be correct, but just based on your knowledge at this moment or what you should have. And I see a C, I see another C, 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 C. Most got C. I see a B. The correct answer, guys, is C. There will be two forces of different types. The one force would be its weight. Remember, the book is just on a table. This is a table. The book is just lying there. It's not being moved or anything. The one force is going to be its weight, which I'm going to denote W. And the other force is going to be the normal force, Fn, the normal force. That's the two types. There are two different types of forces. Okay. And that, guys, now we only have two more problems. This is the type of problem that I used to struggle with, and but maybe you guys will find it easier or whatever. But I used to struggle with these type of problems where one block is attached to another, and they always, and let me tell you right now, you will see a problem like this. I used to struggle with it when I was doing my first year because I used to count sometimes this tension. The one that always confused me was the tension between the two blocks. Okay. Now it makes sense to me, but back then I would always count this thing twice as the force holding this block up and the force pulling down on that block, and but I eventually found out it's the exact same thing. So they have here a 4 kilogram block. Okay, this is the roof or whatever. Then we have a 4 kilogram block. It is 4 kilos. And then tied to this, oh, I just wrote kilograms. A 4 kilogram block. And then tied to this 4 kilogram block is another block, a smaller block, a 2 kilogram block. You see, the problem, the what I learned here eventually when I was studying for my exams in June, what I figured out was to just take each block. I used to try and do the whole thing together, add all the forces and all of that, and it messed up. I would then count one force double because I try to do everything. Here in this case, you need to focus on a single block at a time. That is the advice I will give you. When you see a problem like this, focus on a single mass at a time or a single projectile or whatever object at a time. So we have a 4 kilogram block. It's suspended from the roof. This is the roof here of an elevator. And a 2 kilogram block is suspended from the 4 kilogram block. So this is the roof of an elevator, meaning it's moving. And then the tensions in string 1 and 2 are labeled T1 and T2. So the tension in this string here is T1 and the tension in this string is T2. Can I just to tell you guys something? I used to think back when I was stupid back then. I didn't understand. At least I just tried to get through everything, just trying to survive first year. But I used to think, and this is incorrect now, but I used to think that the tensions in those two ropes would be exactly the same because it's the same rope. Yeah, I was stupid. You can laugh if you want, but that is what I used to think. I would reason it out there and then do some weird mathematics. And once I even got it right, I still don't know to this day how I got that problem right. But I think I made a sign mistake and eventually it worked out in my favor. But it was completely wrong to do it that way. But so we need to work out now. Let's go back to the problem. What do they want us to do? What does this problem want us to do? Let's go check. The problem asks us, okay, use this to answer the following questions. Refer to that picture. When the elevator accelerates downwards, okay, with an acceleration of 2.2 meters per second. Okay, so when the elevator accelerates downwards with that acceleration, the magnitudes of tension T1 and T2 are. So we need to work out T1 and T2. If the acceleration is downwards and the acceleration is equal to 2.2 meters per second squared. Okay, can I just by a show of hands, and this is just if you were to get this problem, let's say you were to get this problem in the exam or a test, who amongst you would be able to do this problem? Who feels confident that they will be able to do this problem? If you don't want to answer, that is fine. I'm just curious. If you were given this problem first off, who amongst you would be able to do this problem confidently? Just by a show of hands. Okay. Okay, I'm not going to call out names, but everyone can see. But yes, let's go. I assume you guys are Vene and those guys, you Yanela, those guys, you either were very good at physics in high school, which I assume most of you were. Otherwise, you wouldn't have chosen to study, take physics, or so you were probably very good at physics in high school, and you are good in physics right now. So let's see. And those of you guys who did not give a thumbs up or anything, that is not a problem. Though we will take the way we go about this problem. Let me just go here and Minentle, thank you for recording. I usually forget. I'm a scatterbrained person. So thank you for recording. So I'm just going to keep the drawing in focus there, or not in focus. Nothing is in focus there. But I'm going to show you can see what is happening at least. So what I do is I would first of all, I'm going to take, we want the tension in both of these ropes, right? So what I'm going to do first, I'm going to isolate the 2 kilogram block, the bottom block. Okay, so I'm going to isolate the bottom block, this block, the one that has the 2 kilogram weight. I'm just going to be looking at it, sorry, and it has tension 2 on it. Okay, and this is the section I'm just going to be looking at block 2 now. So we know that Newton's law says that the sum of all the forces, and this is all the forces in the, and I'm going to be specific now, all the forces in the y direction, although there are no forces in the x direction in this case. So the sum of all the forces in the y direction is equal to the mass times the acceleration of that entire system. So what is the sum of the forces in the y direction? Okay? For block 2, we're just looking at block 2. First of all, there is one force. Let's pick. Let's take upwards as positive. Let's take upwards as positive. Now, what force is pulling this can I just, by indication of a letter there, what force? There are two forces acting on this block. Okay, there's the tension that is pulling this block upwards or holding it upwards, and then it's its weight. Okay, so the tension we're taking up as positive in this case. So the tension would be one of the forces minus the weight of this block. So minus the weight of this block, which is in the opposite direction. Okay, so the tension going upwards, the weight going downwards. Easy enough. Then the mass times the acceleration, okay, of the whole system. So what is the tension? We want the tension. We need to actually write tension 2. We want the tension, so we write T2 minus, what is the weight? The weight is something simple. It is just the mass times the acceleration. In this case, it is 2 kilograms, which is the mass, and I'm not going to put units, I don't have the space, times the acceleration, which is 9,8 in this case. Okay, that is the weight. So now we have the sum of the forces. Okay, now times the mass of the block, which is 2 kilograms. Don't confuse this with the weight. That we here we worked out weight. Here we work out the mass of the whole system, which is 2 kilograms. Now the mass of, what is the acceleration? Can someone tell me what is the acceleration of this entire system? Can someone tell me, please? What would be the acceleration of this entire system? This 2 kilogram block. Not, I'm not talking about the 2 kilogram and the 4. I'm talking about this here that I've drawn here. What would be its acceleration? Is it going to be the same as the elevator, or is it going to be different? Does it have its own acceleration? So can someone just give me a heads up? Do you guys, what is the acceleration going to be for this block? This is the crucial part. What would be the acceleration? Anyone has it to take a guess? I think the reason why I'm asking this question is because people often mix up 9,8. They would write 9,8 here, okay, as the acceleration down. Sometimes that is true, yes. But in this case, the acceleration of this block would be exactly the same as, yes, you are correct, Miss Piwokushe. 2.2. Yes, yes. Avena, you guys are also correct. Sinasipo, you're still typing, so but I assume you're also going to be writing 2.2. That is correct, guys. So it's going to be 2.2 meters per second squared. That's going to be acceleration. Always note that this acceleration here is how fast, or how basically how fast this block is accelerating, okay, or the system of interest, which in this case is just one block. It's going to be 2.2. You know the mistake I used to make? I used to think, okay, this thing is accelerating 2,2 meters downwards, but also there is the acceleration from gravity as well. So actually, I should be adding these two accelerations. That is wrong, guys. Don't do the mistakes I did. This block is just accelerating 2.2 meters downwards, as is been given. Okay, so if we work all of that out, we get that 2.T2. If you were to work all of that out, you would first of all call 2 times 9,8. That is 18,6 or 19,6. It's minus 19,6 newtons equals, let me just rewrite this neatly, minus 19,6 newtons equal to 2 times 2,2, which is 4,4 newtons. Now if we were to take it over, we get T2 is equal to 19.6 newtons plus 4,4 newtons. If I'm correct, that would give me 24 newtons. No. Sorry, I made a mistake here. Quickly, I forgot what. We took upwards as positive, so the accelerator, remember we took upwards as positive, so this acceleration would be negative. It's negative 2,2 because we took upwards as positive. Okay, so this would then be a negative force. This would be negative minus 4.4 which will give me 15.2 newtons. Did everyone get that part? Just for the 2 kilogram block. Did everyone understand this part? So we have T2. Okay. Okay, I see. Most of you guys understood. Just for the 2 kilogram block, we got the tension number 2. So let's go look at the 4 kilogram block. Okay. So the 4 kilogram block. This is the 4 kilogram block. This is why I always draw stuff. Okay. The 4 kilogram block would have T1, tension 1, and then it would have what? What would be the force here? Let's see. So the sum of the forces in the y direction for block number 2 is equal to mass times acceleration. Now we know from previous experience that the mass in this case is going to be 4 kilogram and the acceleration is negative 2,2. Okay. The problem is this forces. What is the sum of these forces? What force is this here? This is T1, guys. This is T1. That's why we worked it out first. So T1 would then be equal to T1. The sum of the forces in the y direction would then be T1 minus T2, which in this case is T1 minus 15,2 newtons equal to negative 8,8. Is that correct? Let me see. Oh, I forgot something. There is another force here. What force did I not include here? There is two forces working downwards. There is the force of tension and what force? Can someone tell me? There is one force missing. The weight, of course, the weight of this block. Okay. In this case, the 4 kilogram block has its own weight that it's pulling down, and it has the tension of block number, the 2 kilogram block. So it would be T1 minus T2, which is 15,2 newtons minus 9,8 times 4. I'm just going to write it like that. 4 times 9,8. That's the weight. And that all is equal to 4 times negative 2 times 2.2. That's 4 times 2 is 8. 4 times 0.2. That is also 8. So 8,8. Negative 8,8 newtons. So if we were to calculate or solve for T1, we take everything over, they can become positive, so it's negative 8,8 plus 4 times 9,8, that is 19.6 doubled. 19.6, 19 twice is 38, am I correct? 38, that's 0.6, that's 1.2, that's 39.2. I don't know, I'm doing quick math here. 39.2, my arithmetic is a bit rusty, plus 15.2, so that's 0.4. Okay, so let's see. That's negative 8,8. 39 plus 15, there is 1, that's 40. That's 44. Am I doing correctly here? Let's check. Okay, that's 50. 54 plus 54.4. If you were to subtract that, it would be. Can you guys just check? Am I doing the correct math here? Is my. Oh, yes, the gravitational force is indeed the one. Did I do sum up these two correctly? 39.2 plus 15, that is 14. That is 40. 14, that's 54. 54.4. Okay. Now 54.4 minus 8,8. What I got here when I worked it out was 45.6 newtons as tension in 1. As the tension in 1. 45.6 newtons. Let's now look at the whole situation together. Okay, so here we have the 4 kilogram block. And this is what I always encourage students to do. Check if your answer makes sense. Check whether it makes sense. Okay, this is T1. T1, the tension in that rope. T2. Can I ask? Okay, now I'm going to ask. By thinking about it, you would expect the tension in rope number one to be higher than this rope because this one here holds the force or holds the 4 kilogram and the 2 kilogram blocks. Okay, so the tension in one, you expect T1 to be bigger than T2 because it holds the weight of both of these blocks. Okay, while the tension T2 only holds the weight of or counteracts the weight of T2. It should always make sense. If I worked out T1 is smaller than the tension here, that would have been wrong because how can that be? It's impossible unless we have negative mass. And we worked out to be it that T1 is equal to 15.2, if you guys can remember. Was that it? No, sorry, T2 was 15.2. So there are two at 15.2 A and C. And then we worked out T1 is 45.6, which is this one. So the correct answer is C. Okay. C is the correct answer. I don't bother checking there. I just make sure that you guys understand. And here is another type of those problems. Whenever blocks are connected, my mind disconnects. This is another problem, but I hope you guys all understood how to do that problem with the block, with the elevator and stuff, because I can guarantee you, that if it's not in the semester test, it is in the exam that you will eventually find that problem again, or at least that type of problem, okay, where they are connected by a rope. Maybe the rope will be, maybe it will be a situation like this. It will be a table, there will be a block here, and there will be another block. There will be a pulley there, and there will be another block suspended by that one. Okay, and this one will have a force, but it will be two blocks connected together. And another problem, we have a block on a horizontal surface, and then we have a slightly bigger block also on the horizontal surface. Let me just scroll there. And there are two forces pushing on both sides. Okay, so this is a 2 kilogram block, and this is a 3 kilogram block. Note I don't write 0.0, but you should do that. Let me just rather do the whole thing. 2.0 kilograms and then 3.0 kilograms. These are the two blocks thrown roughly. And then there is a force 25 newtons pushing this way. And then there is a force of 25 newtons or some force F pushing this way. Okay. The question is, if F, this force here, is equal to 5 newtons, if this force is equal to 5 newtons, okay, what is the magnitude of the force exerted by block 2 on block 1? So what would be the force exerted by block 2 here, this force? Let me just take another color. What is the force that block 2 would exert on block 1? This force F2 on 1. What would that force be? Okay, let's go work it out. What would that force be? So there's the situation. Let me go back to black. So we know that the sum of the forces is equal to the mass times the acceleration. But let's first then work out what is the sum of the forces. Okay, so the sum of the forces in this case would be the 25 Newton force going, we're taking to the positive, we take this direction as positive. Okay, we're taking to the right as positive. You can take either one, it will be the same. So if 25 Newton is positive, then 5 Newton going in the opposite direction would be negative. So this would be a net force. So there's sum of the forces is 20 Newton. Okay. But we know that the sum of the forces is equal to mass times acceleration. So let's work out the acceleration. So acceleration is equal to the sum of the forces over the mass. The sum of the forces is 20 newtons. Ooh, that's terrible. It doesn't look like an N. So the sum of the forces is 20 newtons, and the mass is that is given is. Can someone tell me what would be the mass of this whole system? Because we are now looking at the whole system. Okay, we're looking at the whole system. We're looking at the forces outside of this system. Okay, so we're looking at those two as one system. So what would be the mass? The net force acting on that system is 20 newtons. What would be the mass? Yes, 5 kilograms. 5 kilograms. Okay, so the net mass would be 5 kilograms. So which means the acceleration of that whole system, the acceleration of the whole system would then be 4 meters per second squared. So now we have the acceleration of the whole system. So the system's acceleration is 4 meters per second squared. Now, excuse me. Please note now that we are going to look at the block 2 individually, the 2 kilogram block. Okay? It has a force of 25 newtons acting on it. This way, there's 25 newtons acting on it to the right, and the force that we want is this force, the force of 2, the force that block, which one is it? The force that block 2 has on block 1. So this is block 1. So the force that block 2 has on block 1. We want this force, okay? So we are looking at block 1 because we want the forces that is acting on it due to block 2. And it's this force here, F21. And we know from Newton's second law, sum of the forces equal to mass times acceleration. Now there are two forces acting on the block 2. It's the applied force of 25 newtons minus, in the opposite direction, this force that we want, F of block 2 acting on block 1. And then the mass of this block is equal to 2 kilogram, and it's accelerating at 4 meters per second squared. This is why I worked out the acceleration first from the whole system's acceleration. Now we can find this acceleration, okay? Or not the acceleration, rather this force. Take it to the opposite side. We have 25. We have negative F21 staying on this side. Take 25 over. We have 8 newtons minus 25 newtons. That gives us F21 at the end. The force that block 2 has on this one is equal to 17 newtons. So the force that block 2 exerts on block 1 is 17 newtons. Okay, I hope you guys understand that. And ladies and gentlemen, this is all that we have time for today. It has been a pleasure, and I just want to thank you all for participating. Most of you participated. Those of you who did not participate, thank you for joining in nonetheless. And I hope to see you. Those of you that do FVV, I hope to see you in my class in a few weeks. And then the rest of you guys who are doing PHYV with Dr. Waswa, all the best, and I hope to see you next week. And you can join the other tutors as well. Please, I encourage you to attend if you are busy at that time. If and you have a few hours free on the weekend, or 1 or 2 hours, or maybe there's just something that you're struggling with, please join a session. Ask the demi or the tutor there how to do the certain type of problem, and that's why we send out these emails so that you can ask us beforehand if you have any problem in physics. Let me just get this thing cleared up for you guys. Most of you guys think that we just come here and work out problems. No, our primary aim is to be here if you have a problem. Okay, we only work out problems if no one has any questions regarding their schoolwork. Okay, so if you have problems regarding your schoolwork, email the demi. That's why we send it out in the morning, so that you can email the demi a certain question. The demi will try to figure it out, solve it, and then when you come that afternoon, the demi will have the answer or show you how to work it out. But at least when you send a question, please try to show where or how you approach the problem. Okay, and that is all I have. Thank you guys and all the best. Those of you who have practicals, good luck. See you guys next week. And yes, thanks again for participating. It's nice.